right. This video is going to talk about what's called point-slope form. We've already been writing the types of equations in slope-intercept form. So notice up here at the top, so far we've used y equals mx plus b, knowing what the slope and the y-intercept are for an equation. So given the information below, write an equation of the line with the form m equals -2, so we know our slope, but it goes through the point -1, 3. Now remember, the y-intercept would be the point 0, comma something, right? When x is 0. Since we have a -1 here, this is not the y-intercept. So we need to go find it. Let's take our information, let's plug it into an equation. When y equals 3, right? When the slope is -2, x is -1, right? When y was 3, x is -1. And what we want to do is find the b value, right? What b value would make that true? Because 3 definitely does not equal -1 times -2, so that'd be just 2. We need to add on some number, right? If we subtract 2 from both numbers, we'll find out that b equals, right? 2 minus 2 plus b. 3 minus 2 is 1. And we would have the equation y equals -2x plus 1. Now, that's all well and good, but it's actually not the fastest way to write the equation of a line. Point-slope form, down here at the bottom, again, fancily named slope-intercept form equations, and we know the slope and the intercept, the y-intercept. Well, in point-slope form, all we need to know is the slope and a point. Any point, x1, y1, will do. Notice that in our equation, we've got a couple of different y values and a couple of different x values. x1 and y1 will be the point that we know. X and y alone are any point on our line, right? Kind of like on our equation up here, we left the y and we left the x in our equation because we're saying for any x value, right? We could find a y value that puts a point on our line. Well, the same thing goes down here. For any x value, we could find a y value to find points on our line. But x sub 1 and y sub 1 are the point we know. So for us, -1, 3 here would be the point we know. So we would simply say y minus y1, which would have been 3, is equal to our slope, which up top was -2, times parentheses, make sure you got that quantity there, x minus, and now notice x was -1, so minus the -1 becomes +1. And we have an equation which immediately says we're going through the point -1, 3 with a slope of -2. That's point-slope form. So let's use that a couple more times on here. What if we want to write two different equations that both represent the line shown on the graph over here at the left? Well, notice on our line, right, that infinite line, I forgot the arrows, but infinite line there, right? What we could do is identify a couple of points. So notice here we went left 1, up 2. So this would have been the point, -1, 2. And this point down here, well, hey, that's 1, 2, 1, 2, 3. So we're over at 2, -3. Using those points, we can find a slope, -3 minus 2, right? Y minus y over 2 minus the -1, or 2 plus 1. So this would be -5 over 3 for the slope. Now comes the easy part. Again, if we use this point up here, we can simply say y minus the y value is equal to the slope times x minus -1 minus the x value. So x minus -1 becomes x plus 1. And that would be an equation for our line. We could also say y minus, well, what if we use this coordinate instead? Y minus -3 becomes y plus 3 equal to the slope again times x minus, well, this time x was +2, right? That would also be the equation of our line. Because they're starting at two different coordinates, right, the equations might look a little bit different, but I guarantee you that both this equation and this equation start at two different points on our line and have the same slope, so they're going to coast right along that red line, both of those would be equations of our line. Let's take a look at sort of how that relates to slope-intercept form. So let's write an equation of a line that goes through the points negative 2, 3, and negative 1, 1. We're going to write it in point-slope form and then show that there's a way to write that in slope-intercept form, right? And then if you wanted to, you could always go back to the last screen and show that both of those equations would have the same slope-intercept form equation. I'm not going to do that, but feel free if you want to prove that. It's never a bad idea. First things first, let's get ourselves a slope. So 3 minus 1 over negative 2 minus negative 1. 3 minus 1 would be 2, right? 3 minus 1 was our y value subtracted. Negative 2 plus 1 would be negative 1, right? Those are our x values subtracted. And 2 over negative 1 is negative 2. So now I can write the equation, and I'm going to go ahead and just grab this first equation. Y minus the y value is equal to the slope times x minus the x value. X minus negative 2 becomes x plus 2 right there. So again, using that first coordinate, there's my point slope form equation of my line. Now notice again, they said convert to slope-intercept form. So I'm going to go ahead and do that. I'm first going to take this negative 2, right? And I'm going to distribute into my parentheses here, into my quantity. So y minus 3 equals negative 2x. And negative 2 times positive 2 would be minus 4. Then I'm going to add 3 from the other side, right? I want to get y totally by itself. To be slope-intercept form, I need y equals mx, well that's negative 2x, plus b. Well again, negative 3 plus 3 disappeared on the left, negative 4 plus 3 would be minus 1 on the right, and there is my slope-intercept form equation. Now, if you don't believe me that worked, why don't we use the other coordinate, this negative 1, 1. Y minus the y value is equal to the slope times x, again, minus negative 1, minus the x value, minus negative 1 is plus 1. I'm going to distribute that negative 2 then. So y minus 1 equals negative 2x. Negative 2 times 1 would be minus 2. If I add 1 to both sides, then y equals negative 2x, right? Negative 1 plus 1 disappeared on the left. Negative 2 plus 1 is negative 1 on the right. And notice that we got the exact same equation. All three of these equations, the purple equation, this blue equation up here at the top, and that red equation, they're all the same line. You can always convert point slope form equations, right? Starting at any point that they give us, given the slope and a point, we can write an equation. You can always convert that though into slope-intercept form, right? Remember y equals mx plus b. You can always convert into that form for a slightly easier equation. If you have any questions on that, talk to your teacher. Otherwise, have a great day.